Water is usually a firefighter's best friend, or at least the best tool. It puts out fires by replacing the air source and suffocating the flames. But when water replaces the air in your turnout gear, bad things can happen. Your gear gets heavier, and that's uncomfortable. It also displaces the air in your thermal barrier that insulates you from heat. That water can turn on you quickly and unpredictably, expanding at an explosive rate and making you vulnerable to steam burns and serious injuries. During this video, we'll show you how isodri protective systems manage the moisture in your turnout gear to deliver more reliable thermal protection and increased comfort. Isodri is an engineered system in your turnout gear that manages moisture by a combination of materials that block outside-sourced water, wick perspiration off the body, and resist storing water inside the protective envelope. Here's how it works. The outer shell is molecularly bonded with Teflon F PPE, a durable water repellent finish from DuPont. This helps resist water penetration from outside sources, reducing weight gain and accelerating drying time of your outer shell. But isodri is much more than just an outer shell treatment. Each and every component is engineered to battle the threats presented by water inside your protective envelope. Let's take a look inside isodri. The thermal liner is specially designed to create airspace and enhance moisture vapor transmission. The insulating layers are also molecularly bonded with Teflon F to restrict the absorption of moisture. This helps keep the protective layers of air intact. The example you see here is Lion's 2-layer Aeroflow thermal liner. Notice the top layer is apertured to promote airflow. This means reduced weight, reduced heat stress, and reduced risk of scald burns. Plus, it dries dramatically faster. The isodri liner system works together with the outer shell and moisture barrier to deliver more reliable thermal protection and a much more comfortable garment. The high lubricity thermal liner face cloth is made up of a combination of Nomex filament and spun yarns. The Nomex filament reduces friction for free and natural movement. Sweat is pulled off the body by the spun yarns and spread across the surface of the face cloth. This promotes evaporation and reduces friction to enhance mobility and comfort. Because of this, there is no need to apply Teflon F to the face cloth. Even the wristlets of an isodri system contribute to your safety, comfort, and mobility. They shed water and dry appreciably faster than common wristlets. This helps guard against wrist burns, won't irritate your skin, and don't prematurely wear. To fully appreciate the benefits of a dry system, let's review the role and limitations of the fabric layers within your turnout gear ensemble. The outer shell is your first layer of defense. It resists flames, rips, and tears in order to protect the moisture barrier and thermal liner layers. It's treated with a highly durable water repellent finish to reduce weight gain and shorten drying time. The moisture barrier plays two roles. It keeps the thermal layers dry by preventing the passage of liquids to the inside, while allowing some heat and moisture vapor to transfer away from the body. The thermal barrier is the last line of defense and the most important component in your turnout gear. It provides most of your thermal insulation and plays a large role in the garment's ability to release heat. So, how does the performance of traditional gear differ from isodri protective systems? Let's review a typical run. The moment you don your gear, heat from your body begins to warm the fabric layers. The physical activity of boarding and departing the truck, donning and moving around with your breathing apparatus, and other fire-ground activity increases the heat level inside the protective envelope. Then, there's the heat coming off the structure. Are you starting to get the picture? The protective layers of your turnout are already heated before you enter the hot building, and sweat is collecting in your thermal barrier. Even as your outer shell and moisture barrier are working to keep you dry from external sources, your thermal barrier becomes wet from absorbing sweat. The sweat fills the insulating air spaces within the layers, or battings, and no longer allows moisture vapor to pass outward through the moisture barrier. And once the moisture barrier gets clogged with condensed sweat, it's no longer breathable. As a result, heat stress can occur. This is compounded by the weight factor because a thermal barrier can gain many times its original weight in sweat. That is a lot of extra weight to carry around, further contributing to heat stress. A wet thermal liner is also less comfortable. It clings to the body instead of moving with you. Besides restricting movement, a heavy wet liner can be very clammy and difficult to don and doff. But most importantly, moisture that builds up in your thermal liner stores dangerous thermal energy that can transfer heat to your skin up to 21 times faster than the insulating air it replaced. Add compression to that, and you have a recipe for disaster. This is why we often see second and third degree burns, even though there is no visible damage to the fabric layers. Water also takes longer to cool than air, so burn injury can continue to occur even after you have exited the superheated environment. That's why the ideal turnout system doesn't collect moisture, it sheds it. That's why progressive departments across the world specify isodri protective systems only from Lion Apparel. Here's a quick demonstration that shows the difference between an isodri protective system and a common system. We start with identically sized swatches from a traditional liner and an isodri liner. Their dry weight is similar, each around 6 grams. The average set of turnout gear has about the same yardage as 265 of these 6 by 6 inch squares. We immerse the swatches in water and reweigh. The common liner swatch is now more than 24 grams. If you project that for a full set of gear, it's a weight gain of more than 9 pounds. The isodri swatch is under 13 grams. Projected, that's a gain of less than 3.5 pounds. Each swatch is placed on a heated plate, and temperature sensors are placed on top. Watch the difference in temperature between the two thermal barriers. The temperature on the common thermal barrier rises to 118 degrees Fahrenheit in less than 30 seconds. That's the same temperature as a first-degree burn. Just 10 seconds later, that same thermal barrier has climbed to 131 degrees. That's a second-degree burn. Another 17 seconds, and it's at 152, the temperature of a third-degree burn. The common thermal barrier reaches 200 degrees Fahrenheit in less than 2 minutes. The isodri system is at 97.5. That's less than your body temperature. Now, which one do you want to wear into a fire?